Intramolecular photoreduction. Intramolecular photoreduction. Cross pinnacle is major. You need to remember these points. No other option. Otherwise, you need to learn experimental data. Learning experimental data is better than this one. But it is many data information is there. That is impossible to remember. That's why simple codes are required. That is sufficient. If primary alcohol is a hydrogen donor for normal carbonyl compound, cross pinnacle is major. Clear? Intramolecular photoreduction. Now, in this process, hydrogen transfer followed by CC coupling from hydrogen donor is predominant product. It is a predominant product. You remember this point. Only this point you may expect a question, and that is almost all equal to normal CC coupling reactions. When intramolecular photoreduction is appeared anywhere, don't apply pinnacle product. Pinnacle product never exists. On that time, hydrogen transfer followed by CC coupling. See this. Is it methanol giving hydrogen transfer? Is it methanol giving hydrogen or not? See, methanol, CH3OH, it is giving hydrogen from carbon or oxygen? Carbon. Carbon giving hydrogen. So not, that's why it is a hydrogen donor. Hydrogen transfer followed by carbon-carbon coupling. See, it is giving hydrogen. It is also coupling with this carbon. See, hydrogen transfer followed by CC coupling. Same. When intramolecular is given, blindly apply this point only. Don't write pinnacle product. Even they will give an option. Pinnacle product they will give an option, but that won't exist. Intramolecular photoreduction always give transfer of hydrogen followed by CC coupling with hydrogen donor. Clear? Now, see the example. Like this they will give, they won't give hydrogen donor. Hydrogen donor present within the molecule, that is called intramolecular. Now is hydrogen donor? This one. Now this carbon donates hydrogen to oxygen. When hydrogen donated to oxygen, then here one radical is there, this radical take hydrogen. Now this carbon carry radical or not? Now this radical both combine together forms CC coupling. So first what happens? Hydrogen transfer takes place. What is hydrogen transfer product? Here carbon carry pH, right? Now is it a radical mechanism? So now this oxygen carry hydrogen. Who is giving that hydrogen? This carbon. In this, who is giving this hydrogen? Methanol. Methanol is coming from externally. But here this carbon present within the molecule, that is called intramolecular. Now this carbon carry only one hydrogen. Now already pH is present. Now if you break this bond symmetrically, here you will get one radical or not? Now the two radicals, see, this carbon donating one hydrogen followed by CC coupling. This carbon donating one hydrogen on oxygen followed by CC coupling. In this process, hydrogen transfer followed by CC coupling. Whichever atom donates hydrogen, same atom undergoes CC coupling. Which atom is donating hydrogen? Carbon or not? This carbon donates hydrogen, same carbon forms CC bond. This will helps in nourish 1, nourish 2. If you take simple, there you will stuck. If you not remember these points, there you will suffer. 100% I am saying. If you are unable to remember these points, you will stuck at especially nourish 1. Nourish 1 you will suffer. What is nourish 1? Alpha cleavage. Here we are cleaving. There you will suffer. Frankly I am saying intramolecular nourish 1. There you will suffer. That's why first you clear about reduction. When you will get pinochle product, when you will get simple product, when donor become a transfer of hydrogen and CC coupling product. So this carbon donates hydrogen to oxygen. Same carbon forms a CC coupling with this carbon. So now can I write this? This and this are coupled together, and finally this is the answer. Can I write carbon? Here carbon carry pH. Here hydrogen is present, and this carbon there is a new bond, and OH, and what is one more? pH. Hydrogen coming from carbon, same carbon helping from CC coupling. This point you need to remember. Same carbon helping. Now this carbon donating this hydrogen means it is satisfying carbon as well as oxygen or not? One atom in a molecule satisfying oxygen and carbon. Satisfying oxygen by donating hydrogen. Satisfying carbon forming a CC bond. That's why this concept is very, very important. In your examination, these points are not easy to recollect. Right now, your fresh topic is very fresh, very easy to understand. Group of reactions, if they come, you don't know what to do. That's why try to write such a way that so that you can recollect within seconds. That is a way of preparing for exam. That is called art of preparing organic concepts. Everyone can understand. Based on faculty, everyone can understand on that time. But open after 1 week or open after 1 month, topic is fresh for you because already it is disappears. That's why conceptual knowledge is very, very important. So give the answer for this. C double bond O CH3. Now if you understand clearly, you will give the answer. Same, this and that same. So this is given in CSR. I will show this question in photochemistry. Previous year questions. This is given in CSR for 2 marks. So what is your answer? Benzene carbon C. Is it CH2 or not? CH2, this become OH and this is CH3. That is the answer, right? This carbon donates hydrogen to oxygen and same carbon coupled with this. Hydrogen transfer followed by CC coupling. This is called intramolecular photoreduction. Now this one, whichever hydrogen is very close to carbonyl, only that particular carbon can undergo coupling. So this and this. Here this carbon carry how many hydrogens? 2. So break this bond. This hydrogen transfer here, this radical combined. Hydrogen transfer followed by CC coupling. Why this carbon is coupling? Why not other carbons? Any reason? You may ask, sir, why this carbon donates? Why not this carbon donates? Why this carbon is donating? Why not adjacent carbon is donating? Is it right? Why this carbon is donating hydrogen to this oxygen? Reason is, we are getting a symmetry in molecule. 2 rings are same or not? Now 2 rings can develop a chair form. Decanol. You will get a decanol structure. This is called decanol. Chair form, and here one more chair form, and this is alcohol. Okay? This hydrogen is above and this hydrogen is below. So that's why here I can write thick line and here I can write dotted line. This is a measure. Stereochemistry also they will ask. This is called trans decanol. Decanol. Decaline nothing but only 2 rings without hydroxy. So this is called decanol. Which decanol? Trans decanol. Suppose your hydrogen is there. Suppose over here if I write hydrogen, only hydrogen, what is this? Decaline, trans decaline. Okay? So now decanol is measured. This question given in exam with stereochemistry. Why this carbon hydrogens are donated to carbonyl group? Key reason is, when this hydrogen donates on oxygen, there is a formation of a biradical. That biradicals are very closer, they are ready to close. Suppose if you remove this one, they won't close. They are separated by some distance. But whenever if they are closing, ring becomes unstable. But whenever these 2 radicals are very closer, they can couple with very faster and they are developing stable ring. That is the advantage. You need to remember, like this some points you need to remember. Based on the molecule, you can guess question. Sometimes this carbonyl they will give here. Remember, this carbonyl every time they won't give here. They will give this side or this side. Your answer is remain same. Answer never changes. Suppose if carbonyl is here, so opposite, see 1, 2, 3, 4, 5, 6. Suppose if carbonyl group is present here, 1, 2, 3, 4, 5, 6, this one will donate here. They will arrange a skeleton in such a way that stable arrangement responsible to transfer the hydrogen followed by CC coupling. If carbonyl is given here, anywhere if they given, your answer is same. Clear? This molecule even in parts interconversions is given. Intramolecular. Same. Your answer is remain same, oxygen. It will couple here. This is OH and this is pH. This and this coupled together. This hydrogen donates on oxygen, this carbon coupled. Here also remain same. Here isopropyl. This carbon donates hydrogen to oxygen, then carbon-carbon coupling. So break this carbon hydrogen bond, this hydrogen transfer on oxygen, now carbon undergo coupling. So that is photo reduction. So these carbon 2 hydrogens are there, break this carbon hydrogen bond, this radical couple with this one. So break this bond, add this hydrogen on this oxygen, create a bond between carbon and carbon. So that is end of photo reduction. Now after photo reduction, next is photocycloaddition. Photocycloaddition, also called Paterno-Büchi reaction. PB. So I will casually say as PB, I won't say every time. Paterno-Büchi like that, PB reaction. Paterno-Büchi reaction, also called photocycloaddition. If you understand photo reduction clearly, limitations of PB you can understand clearly. Okay, be prepared. Try to keep some selective concepts in your mind. Photo reduction, after that Paterno-Büchi reaction. Next, right, see, 2pi 2pi cycloaddition reaction between carbonyl compounds and olefins or alkynes. 2pi 2pi cycloaddition between carbonyl compounds and olefins and alkynes is known as Paterno-Büchi reaction. It is a cycloaddition reaction. They will ask this point, which among the following is a cycloaddition reaction? Paterno-Büchi is a example of 2pi 2pi cycloaddition. Paterno-Büchi is a pericyclic reaction. It is carried out under photochemical. PB under photochemical, Diels order under thermal. That's why if you learn photochemistry pericycle at a time, there is a clarity is there. Which is photochemical allowed, which is thermal allowed, like that. It is a cycloaddition reaction established between carbonyl and alkyne. So normally if I take carbonyl compound reacts with alkene. So this is lambda of carbonyl compound. Now here you will expect oxetane. Same carbonyl compound on reacting with a alkyne triple bond. Lambda of carbonyl compound, here we will expect a oxetene, 4-membered oxetene. This oxetene is unstable, they undergo ring opening. So this is further gives alpha comma beta unsaturated carbonyl compound. This is key point. Oxetene is unstable, so this is not going to survive. Oxetene is unstable, but this is stable. Oxetene is stable due to sp3 hybridization. Carbonyl compounds plus alkane 2pi 2pi cycloaddition will give oxetane. Here oxetene. Oxetene is unstable, undergo ring opening, will give alpha comma beta unsaturated carbonyl. See, this is carbonyl compound and here I am using a olefin. So photochemical I am using this. So on that time you will get oxetene. So these two will undergo coupling. Oxetene. Same carbonyl compound is going to react with the triple bond, same photochemically. Here it is 2 pi 2 pi cycloaddition. So here your product is remain same. Here 2 methyls, and what is your answer? Triple bond become double bond. This is called oxetene. Oxetane. This is oxetane. This is oxetene. After that they will undergo ring opening. So this bond will migrate here. This will migrate here. So finally, this and this, there is a double bond formation, single bond, double bond, and this one. Alpha comma beta unsaturated carbonyl. This answer. If a triple bond is given, don't stop reaction up to here. Your answer is alpha comma beta unsaturated carbonyl. So then write the characteristics of PB reaction. Okay. So first, irradiate with suitable wavelength of carbonyl compound. Irradiate with suitable lambda of carbonyl compound. Reaction excited states are N2 pi star singlet and N2 pi star triplet. Two are possible. Pi star singlet and triplet both are possible. Reaction excited states are N2 pi star singlet and N2 pi star triplet. N2 pi star singlet is stereo specific. And N2 pi star triplet is non-stereo specific. Stereo specific and non-stereo specific. Irradiate with suitable lambda of carbonyl compound. Reaction exit states are N2 pi star singlet and N2 pi star triplet. N2 pi star singlet is stereo specific every time, and this is non-stereo specific. Triplet is non-stereo specific. Then reaction intermediates are reaction intermediates are 1,4 biradicals. Reaction intermediates are 1,4 biradicals. See, during cycloaddition, excited state carbonyl compound combines with ground state olefin and forms a weak charge transfer complex. It will forms a weak charge transfer complex known as exciplex. So you need to remember this word exciplex. Exciplex is a charge transfer complex formed between excited carbonyl and ground state olefin. During cycloaddition, excited state carbonyl compound combines with a ground state olefin. Ground state olefin forms a weak charge transfer complex that is known as a exciplex. That will give exciplex. Okay, next, always reaction proceed with stable 1,4 biradical. Stable 1,4 biradical. Paterno-Büchi reaction proceed with stable 1,4 biradicals only. Reaction proceed with a stable 1,4 biradical. Okay. Cyclization of 1,4 biradical leads to oxetane. Oxetane formation takes place. Always reaction proceed with stable 1,4 biradical. You try to develop such a way that you will get a stable 1,4 biradical. So these biradical concepts are very important. 1,4, many concepts, biradicals will come. You try to remember intermediates. Every time intermediate you need to focus. What kind of intermediates are possible in that system? Intermediate exciplex. What is the meaning of exciplex? So first, this is carbonyl compound olefin. Carbonyl compound is irradiated by a light. Then it will take that energy and excite it. Once if it is excited, it will form a charge transfer complex with olefin. So means a complex formation where excited partner combined with a ground state partner, it starts is going to be transferred from activated partner to ground state partner. That intermediate is called exciplex. After formation of exciplex, then only formation of radical takes place. 1,4 biradical formed. Okay, so they are formed before 1,4 biradical. There is exciplex formation takes place. First excitation, then charge transfer complex, then 1,4 biradical, then oxetane. Okay, this is oxetane formation. See, if olefin is electron rich, initially forms CO bond, followed by CC bond. So this point you remember. If olefin is electron rich, initially CO followed by CC. If olefin is electron deficient, if olefin is electron deficient, initially forms CC bond, followed by CO bond. So this point you remember. So they are shortcuts to attempt oxygen formation in Paterno-Büchi reaction. So always carbonyl compound combining with olefin or not? Olefins are two types, electron rich, electron deficient. Paterno-Büchi reaction taking place with electron rich olefin. First bond is CO, next bond is CC. Suppose if olefin is electron deficient, first bond is CC, next bond is CO. These points you need to remember. Exiplex is a charge transfer complex formed between excited molecule and ground state molecule. During that particular process, it is a transition state where charge is transferring from excited partner to ground state partner. That is called exiplex. Exiplex is a charge transfer complex. This point they will ask in exam. Which among the following is a charge transfer complex? Exiplex. Statement question. So this is given in set exam. This point. Which among the following is a charge transfer complex? Exiplex in PB reaction. Set question it is. So this is also gate question. Which among the following reaction? 1,4 biradicals are intermediates. 1,4 biradical intermediates in PB reaction. Reaction exit state in PB reaction is N2 pi star singlet as well as triplet. Both are possible. Be careful. Singlet same reaction. Triplet also same reaction. But triplet carry multiple products. Singlet carry only one product. Stereo specific means only one product. See, just listen. If I take any carbonyl compound, so here two bonds are present. We don't know what kind of bonds they are. R and this is R. Now I am taking a olefin. So when olefin is combining photochemically, then see this carbon and this carbon combining with oxygen and carbon or not? This carbon combines with oxygen. Listen, here this carbon combines with oxygen. This is called CO bond. CO bond. Later on, CC bond. Is it C and C or not? CC bond. And this is called CO bond. Suppose if this olefin is electron rich. If this olefin is electron rich, first CO bond, next is CC bond. Suppose if first CO bond formation takes place. 1, 2, 3, 4. 1,4 biradical or not? Suppose if it is electron deficient, first is CC bond, later on CO bond. You focus on these two bonds only. Your answer decides on these two. Clear? So answer depends on olefin. Olefin may be electron rich or electron deficient. If it is electron rich, apply this point. First this bond, CO bond. Later on CC bond. It is electron deficient, CC bond. Later on CO bond. Clear? Now see the mechanism involved in this one. First, which partner is involving? Carbonyl compound is a real partner which is activated. This is R and this is R. You write R dash, R dash. Now, this is on photochemical irradiation. Then what happens? Initially undergo excited. Here R dash, R dash. So what is the state here? N2 pi star. What is this? Singlet. N2 pi star singlet. Now, this is activated. Activated molecule, singlet, it is undergo. Don't write, just listen. Intersystem crossing. Intersystem crossing responsible to give. This is R dash and this is R dash. What about next? N2 pi star, triplet. Okay. Now it is combining with a ground state partner of olefin. See, I am taking a unsymmetric olefin. So this is methyl. This is methyl and here also I am taking methyl. Definitely try to take unsymmetric olefin only. So is it a ground state? No, it is excited state triplet. Now here ground state. So this I am writing S0. What about here? T1. Now these two undergoing charge transfer complex. Excited partner combined with ground state partner forms a charge transfer complex. Now charge transfer complex formation takes place by R dash over here. Okay, so this is called charge transfer complex. This is charge transfer complex. Now this charge transfer complex, two possibilities are expected. Okay, so this is one condition, other one is second condition. See, this will be rotated. So if it is rotated, now you will get double bond above and this becomes below. It is also called charge transfer complex, R dash and this is R dash, here two methyls here. Okay, this is exiplex. So later on see, this is Wisted it is, triplet is participating now. Now here singlet or not? This is singlet. Now singlet is going to combine with olefin. Same olefin, one more time I written. Now singlet is participating in reaction. When singlet participate in reaction, two exiplex formation takes place. C double bond O, here R dash, R dash. This is one exiplex. R, you will expect one more. So whichever is stable, that we need to consider. This is one more. This is also exiplex. Now singlet combined with olefin, triplet combined with olefin. Two possibilities are not. Reaction excited, how many I given? Two I given. Singlet and triplet. Singlet is a stereospecific, triplet is a non-stereospecific. Now this exiplex, first, suppose if it is electron rich, this radical, four are ready to participate. First what happens, see this radical combine together. So after combining these two, now you may get a 1,4 biradical or not? This is R dash and what is this? R dash. So what is this? 1,4 biradical. Intermediate. So after 1,4 biradical, what is your answer? These two are cyclized together, then you will get this answer. This is R dash, here methyl and methyl. That is the answer. Now is these two radicals are stable or not? See, it is a tertiary radical or not? Here donor is there, tertiary radical. Suppose see if this is participating in reaction, first these two combine together. So here R dash, here radical. Right? Now these two radicals are combined together. After combining these two radical, now this is R dash, here 2 methyl. Right? Is it stable radical or unstable? This is found to be unstable radical, and what about this? This is a stable radical. See one point, what I given. After exiplex formation, next one point I given. Always reaction proceed with a stable radical. That point I given C. Always reaction proceed with a stable. This is stable and this is unstable. So now this cyclization is found to be, it is found to be major and this is found to be minor in case of triplet participator. Here also same mechanism or not? See, in this case what you will expect? Intermediate is here R dash, here methyl and here methyl. Will you expect 1,4 biradical? Is it 1,4 biradical or not? Okay. Now this is combined together and forms cyclic product. This is R dash, here methyl and this is methyl. Is it major or minor? Major. Now this is one more possibility. So this particular carbon carry 2 radicals, right? Now see, here unstable radical, but here see stable radical. Now this is responsible to give. This is R dash, it is R dash. This is found to be minor. Total how many products you will get? 4. Suppose if singlet is participating, this is major. If triplet is participating, this is major. But maximum singlet. Don't consider triplet because triplet will give multiple products. Right. In both cases you will get hexaplex. Hexaplex is common. Hmm?